Here's a fact that should terrify you. The average person can survive 3 weeks without food. But without water, you are dead in 72 hours, 3 days. That is all you get. During World War II, families across Europe and America understood this reality better than anyone alive today. Bombs destroyed water mains overnight. Droughts emptied reservoirs. Enemy forces poisoned wells and contaminated rivers. And yet families survived. Some stored water for 2 years or longer without it going bad. Without electricity, without refrigeration, without expensive chemicals or modern filtration systems. They used cistern designs that had been perfected over 5,000 years of human history. Underground tanks that kept water cool and dark. Filtration systems built from nothing but sand, gravel, and charcoal. Treatment methods that killed bacteria using ordinary household bleach. These 10 designs are not primitive. The Roman Basilica Cistern held 80,000 tons of fresh water. The British military developed field purification systems that still outperform many modern filters sold today. And here is the terrifying part. Most families today have less than 3 days of water stored in their homes. One broken pipe, one contaminated reservoir, one natural disaster, and the clock starts ticking. 72 hours. That is all you have. Unless you know what wartime families knew. Number 1, underground brick and stone cistern. The oldest and most reliable water storage design in human history. Underground brick and stone cisterns have been keeping water fresh for over 5,000 years. The Romans built them, the Byzantines perfected them. And during World War II, families across Europe relied on them when everything else failed. The design is elegantly simple. You dig a hole in the ground. Line it with brick or stone. Coat the interior with hydraulic plaster to make it waterproof. Cover it with a sealed lid. And you have a water storage system that can last centuries. Why does it work so well? Underground temperatures stay constant year-round. 6 feet below the surface, the temperature hovers between 50 and 55 degrees Fahrenheit, regardless of whether it is summer or winter above ground. This matters enormously for water storage. Bacteria multiply rapidly in warm water. At 70 degrees, bacterial colonies can double every 20 minutes. At 55 degrees, that growth slows to almost nothing. The water stays safe for months or even years. Total darkness is the second advantage. Algae needs light to grow. Even small amounts of sunlight filtering into a water container will eventually produce green slime. Underground cisterns receive 0 light. Algae cannot grow. Period. During World War II, British families with basement cisterns survived weeks without municipal water service. The concrete or brick tanks their grandfathers had built decades earlier became life-saving infrastructure overnight. A properly constructed underground cistern can store water safely for 2 years or longer. No electricity required. No expensive filtration, just ancient engineering that works. The Romans figured this out 2,000 years ago. The technology has not improved because it did not need to. Number 2, corrugated galvanized steel tank. In 1857, a British inventor named John Carter patented something revolutionary: the corrugated galvanized steel tank. The corrugated ridges made thin steel sheets incredibly strong. The galvanized zinc coating prevented rust. Suddenly you could build large water tanks cheaply and quickly using materials that lasted decades. By World War II, these tanks were everywhere. Farms across America, Australia, and Britain used them for livestock water, irrigation, and household supply. Military bases installed them for emergency water storage. The design spread because it solved every practical problem. Corrugated steel tanks are lightweight compared to concrete or brick. One person can assemble a small tank in a few hours. They can be placed above ground or partially buried. They can be moved if necessary. The galvanized coating is the key to longevity. Zinc naturally protects steel from corrosion. A well-maintained galvanized tank can last 25 to 50 years. For water storage, these tanks offer one critical advantage over plastic. Steel blocks all light completely. Algae cannot grow in total darkness. Plastic containers, even dark-colored ones, allow small amounts of light penetration that can eventually support algae growth. During World War II, rural families relied on corrugated steel tanks, connected to rainwater collection systems. Gutters channeled water from rooftops into the tanks. Simple screens filtered out debris. The water stayed fresh for months. Modern versions of these tanks are still manufactured today. They remain one of the most cost-effective long-term water storage solutions available. Your great-grandparents probably had one on their property. The technology works exactly the same today as it did 80 years ago. Number 3. Ferrocement cistern. What if you could build a concrete cistern without expensive forms and professional construction? That was the problem Ferrocement solved. Ferrocement is a construction technique that uses thin steel rods and wire mesh covered with cement mortar. The result is a structure that is 70% stronger than regular concrete, but can be built by anyone with basic skills. The technique became popular during and after World War II, particularly in developing regions where materials were scarce but labor was available. Here's how it works. You build a frame from thin steel rebar. Cover the frame with layers of wire mesh or chicken wire. Then apply cement mortar by hand in thin layers until the structure is solid. No wooden forms required, no heavy equipment needed. For water cisterns, Ferrocement is nearly ideal. The wire mesh reinforcement makes the structure incredibly resistant to cracking. Cracks are the enemy of water storage because they allow contamination to enter and water to leak out. Ferrocement cisterns rarely crack even after decades of use. The cement mortar creates a naturally alkaline environment. This high pH inhibits bacterial growth and keeps water fresher longer. A skilled person can build a Ferrocement cistern in a few days using inexpensive materials. The finished tank can hold thousands of gallons and last for generations. During water emergencies after World War II, relief organizations taught Ferrocement construction to communities around the world. The technique allowed families to build their own water security using local materials. If you have basic construction skills, Ferrocement might be the most practical cistern design you can build yourself. The materials cost less than commercial tanks, and the result is stronger and more durable. Number 4. Poured concrete cistern. For permanent water storage, nothing beats poured concrete. Concrete cisterns have been standard construction since the early 1900s. They can be built in any size from a few hundred gallons to tens of thousands. They last essentially forever with minimal maintenance. During World War II, many American homes already had concrete cisterns in their basements or buried in their yards. These tanks had been installed decades earlier when municipal water systems were less reliable. When emergencies struck, these old cisterns became critical infrastructure. The construction process is straightforward, but requires more equipment than Ferrocement. You excavate a hole and build wooden forms in the shape you want. Install steel rebar reinforcement inside the forms. Pour concrete and let it cure. Remove the forms and apply waterproof coating to the interior. The waterproof coating is essential. Concrete is naturally porous and will absorb water without proper sealing. Traditional coatings included hydraulic lime plaster, bitumen, or specialized waterproofing compounds. Concrete cisterns offer several advantages for long-term water storage. The thermal mass of thick concrete walls keeps water temperature stable. Underground concrete cisterns maintain 50 to 55 degree temperatures year-round. This cold, stable environment dramatically slows bacterial growth. Concrete also blocks light completely. Combined with proper sealing and covers, concrete cisterns can store water safely for years. Many homes built before 1950 still have functioning concrete cisterns that could be restored to service. If you have an old property, check your basement or yard. You might have water storage infrastructure already installed and waiting to be used. Number 5, sand and gravel filtration system. Before modern water treatment plants existed, humans purified water using the same materials nature uses: sand, gravel, charcoal. This filtration method is thousands of years old. Roman engineers used it, colonial Americans used it, and during World War II, military units built field versions that purified water from rivers, streams, and bomb craters. The system works through biological and physical processes. You layer materials in a container with gravel at the bottom, sand in the middle, and charcoal on top. Contaminated water enters through the charcoal layer and slowly percolates down through the sand and gravel. The charcoal absorbs chemicals, removes odors, and traps some bacteria. The sand creates a biological layer called the Schmutzdecke, where beneficial bacteria consume harmful microorganisms. The gravel provides drainage and prevents the sand from compacting. The key word is slowly. Water must move through a slow sand filter at a rate of about 0.4 meters per hour. At this speed, the biological layer has time to work. Faster flow reduces effectiveness dramatically. A properly constructed slow sand filter removes up to 99% of bacteria and parasites from contaminated water. Not as effective as chemical treatment, but remarkable for a system built from natural materials. During World War II, military engineers built large-scale slow sand filters at base camps and field hospitals. Smaller versions could be constructed in hours using available materials. The technology is still used today in developing regions and by preppers who want water purification that works without electricity or replacement parts. Combined with cistern storage, a sand and gravel filter can provide safe drinking water indefinitely using nothing but gravity and patience. Number 6, first flush diverter system. The dirtiest water from any rainstorm is the first water that falls. Think about what accumulates on your roof between rainstorms. Bird droppings, dust and pollen, dead insects, leaves and debris, chemical residue from air pollution. When rain finally comes, the first few minutes of runoff wash all that contamination directly into your collection system. If that dirty water enters your cistern, it introduces bacteria, organic matter, and pollutants that will degrade your stored water. The solution is brilliantly simple. Divert the first flush away from storage. A first flush diverter is a section of pipe that fills with the initial contaminated runoff and then automatically redirects cleaner water to the cistern. Once the diverter chamber fills, a floating ball or simple valve seals it off. All subsequent rainfall flows to storage. The concept has been used for centuries. Historical records show farmers diverting initial runoff away from drinking water cisterns as far back as the 1700s. During World War II, military water collection systems incorporated first flush diversion to improve water quality in field conditions. The cleaner the water entering storage, the longer it stays fresh. Modern first flush diverters can be purchased commercially or built from standard plumbing parts. A typical system diverts the first 1 to 2 gallons per 100 square feet of roof area. This single addition to a rainwater collection system dramatically improves water quality. Less contamination entering your cistern means less treatment required and longer safe storage times. If you're collecting rainwater for storage, a first flush diverter is not optional. It is essential. Number 7, clay and terracotta storage. Before metal tanks and concrete cisterns, humans stored water in clay. Terracotta storage vessels have been found at archaeological sites dating back over 8,000 years. The technology is simple. Shape clay into a container. Fire it at high temperature to create a hard, waterproof surface. Fill with water. Clay has natural properties that benefit water storage. Terracotta is slightly porous, which allows microscopic amounts of water to seep to the outer surface and evaporate. This evaporation creates a cooling effect that keeps the water inside several degrees cooler than ambient temperature. In hot climates, this evaporative cooling was critical for keeping stored water fresh before refrigeration existed. Clay is also naturally antibacterial. Studies have shown that certain clays actively kill bacteria on contact. Water stored in quality terracotta vessels often stays fresher longer than water stored in other materials. During World War II, terracotta vessels were still common in rural areas and developing regions. Families who lacked access to metal or concrete continued using clay storage methods their ancestors had used for generations. The limitation of terracotta is size. Large clay vessels are heavy and fragile. Most practical terracotta storage is limited to a few gallons per container. For small-scale emergency water storage, terracotta remains an excellent option. A few large clay vessels stored in a cool basement can provide drinking water for days or weeks. The natural cooling and antibacterial properties help keep that water fresh without any chemical treatment. Number 8, wooden barrel system. Until the early 1900s, almost everything was stored and shipped in wooden barrels. Water was no exception. Wooden barrels made from oak, cedar, or other tight-grained woods can store water effectively for months. The wood swells when wet, creating watertight seals between the staves. Certain woods, like cedar, have natural antimicrobial properties that help keep water fresh. During World War II, wooden barrels were still common on farms and in rural areas. They served as backup water storage when more modern options were unavailable. The construction technique, called cooperage, is an ancient craft. A skilled cooper assembles curved wooden staves around circular ends, binding them with metal hoops that tighten as the wood expands. For water storage, barrel selection matters. Oak barrels, previously used for whiskey or wine, will impart flavors to stored water. This is not harmful, but can make the water taste strange. New barrels, or barrels previously used only for water, are preferred. Cedar and cypress barrels offer natural rot resistance and antimicrobial properties. Water stored in cedar barrels often stays fresh longer than water in oak or other woods. The main limitation is duration. Wood is organic material that eventually degrades when constantly wet. Wooden barrels typically last 5 to 15 years with regular use before needing replacement. For emergency water storage, wooden barrels remain a viable option if you can find them. Antique barrels are collectible, but functional versions are still manufactured for winemaking and food storage. Number 9, chlorine and bleach treatment. The single most important water purification discovery in human history, chlorination. Adding small amounts of chlorine to water kills bacteria, viruses, and most parasites. The technique was developed in the late 1800s and became standard practice for municipal water systems by World War I. During World War II, military forces issued chlorine tablets to every soldier. The ability to purify water from any source was critical for operations in remote areas where clean water was unavailable. The household version of this technology is ordinary unscented bleach. Standard liquid bleach contains sodium hypochlorite, the same active ingredient used in municipal water treatment. 4 to 5 drops of regular unscented bleach per gallon of water will kill most harmful microorganisms within 30 minutes. For long-term cistern storage, proper chlorination can keep water safe for 2 years or longer. The EPA recommends 8 drops of 6% bleach per gallon for emergency disinfection. After treatment, water should have a slight chlorine smell. If it does not, repeat the treatment and wait another 30 minutes. Chlorine does dissipate over time. For cistern storage lasting more than 6 months, periodic retreatment may be necessary. Testing kits can measure remaining chlorine levels to determine when additional treatment is needed. This is not complicated chemistry. Wartime families learned to treat stored water with bleach and kept their families healthy through emergencies lasting weeks or months. And the same technique works identically today. A single bottle of bleach, costing a few dollars, can purify hundreds of gallons of water. Number 10. Dark and cool storage principles. Every cistern design in this video shares 2 fundamental principles. Keep water dark. Keep water cool. These are not suggestions. They are requirements for long-term storage. Algae needs light to photosynthesize. Even dim light filtering through a translucent container will eventually support algae growth. Within weeks, you will see green discoloration. Within months, thick slime will coat every surface. The solution is total darkness. Opaque containers, underground storage, covered tanks that block 100% of light penetration. Temperature matters equally. Bacteria reproduce rapidly in warm water. At 70 degrees Fahrenheit, bacterial colonies can double every 20 minutes under ideal conditions. At 55 degrees, that reproduction rate drops dramatically. At 40 degrees, most harmful bacteria become essentially dormant. Underground storage naturally provides both conditions. 6 feet below the surface, temperatures stay between 50 and 55 degrees year-round, regardless of surface weather. Underground spaces receive 0 natural light. This is why underground cisterns have been the gold standard for water storage since ancient times. The Romans knew it. Medieval Europeans knew it. Wartime families knew it. If underground storage is not possible, insulated above-ground tanks in dark basements or shaded areas can approximate these conditions. The key is minimizing temperature fluctuations and eliminating light completely. No amount of chemical treatment can overcome poor storage conditions. Bleach will kill bacteria initially, but if warm temperatures and light exposure continue, recontamination is inevitable. Dark and cool. These 2 principles make every other technique work. 10 designs, 5,000 years of proven technology, water storage that lasts 2 years without going bad. This is not theoretical knowledge. This is survival history. During World War II, these cistern designs kept families alive when infrastructure collapsed. Underground brick tanks, galvanized steel reservoirs, sand and gravel filters, simple chlorine treatment. None of it required electricity. None of it required expensive equipment. None of it required expertise beyond basic construction skills and common sense. The 72-hour clock is real. Without water, your body begins shutting down in 3 days. Municipal systems are more fragile than most people realize. One disaster, one attack, one prolonged drought, and millions of people could find themselves without safe drinking water. Wartime families understood this vulnerability. They built water security into their homes using techniques that had worked for thousands of years. We have somehow forgotten what they knew. The Romans stored 80,000 tons of water in a single cistern. The Byzantines built underground reservoirs that supplied entire cities. British families survived weeks of bombing with basement cisterns their grandfathers built. The technology has not changed. The human body still needs water every 72 hours. The methods that worked during World War II work identically today. Dark storage, cool temperatures, proper treatment, simple filtration, 10 designs. Your family's water security could start this weekend. The question is not whether you can afford to build water storage. The question is whether you can afford not to,